So the molecular orbital of N2. So first, if we just look at the electron configuration of nitrogen, we have 1s2, 2s2, 2p3. But, okay, yeah. So if we draw that as in terms of molecular orbitals, we can expect 1s here, and then the anti-bonding and bonding, but it's gonna be filled up anyways, so we really don't have to consider the 1s, because we already know the anti-bonding is gonna be filled no matter what, because it's already 1s2 and we're already at the second principal quantum number, so we don't really have to consider the 1s, and straight to the 2s. Okay, I'm gonna draw it better than that though. So 2s, and then this is in terms of energy, this line here, energy, yep, 2s, and then since it's 2s2 here, so 1 2 1 2. If we fill up the molecular orbitals, it's 1 2 1 2, and the lower part will be the sigma, since it's in the 2s we only have sigma bonds here, so sigma 2s2 and sigma star 2s2. So basically, since the bonding and anti-bonding are all filled, basically it will even out or cancel out. And for here, now we have the 2p's, so 2p, 1 2 3, 2p, and oh, and since it's nitrogen, well, okay, I'm gonna get back to that later. So here, yeah, since it's nitrogen, we will have the sigma on top of the, or above the pi, because it interacts with the 2s, so the sigma has to be higher in the energy compared to the pi. So we draw the pi molecular orbital below the sigma, so this would be pi 2p star, no, pi 2p and sigma 2p, and pi 2p star, sigma 2p star, where normally it would be more like sigma 2p, pi 2p, pi 2p star, and sigma 2p star. Okay, and then we have the 2p's here, like this. And since it's 2p3, we fill it up. 1 2 3, 1 2 3. And then now we fill it up from the bottom of the energy. So we have in total we have 6 electrons here. So 1 2 3 4 5 6. So no electrons occupy the non-bonding, the anti-bonding molecular orbitals. So we can expect a double bond here, or no, a triple bond here. Since this molecular orbital is filled and these two are filled, so we can expect a triple bond. And since no electrons occupy the anti-bonding, we don't expect any cancellations here. So therefore it should be something like this, and probably 2 electrons here. And the bond order, if we consider the bond order, we have 2 electrons and 2 electrons, 2 electrons, 2 electrons. So we have a total of 4 pairs and 8 electrons in the bonding molecular orbital, and we only have 2 electrons at the anti-bonding. So subtract by 2 and divided by 2, we have 6 divided by 2, which is 3. So the bond order is 3. And this also supports that. We have 3, we have a triple bond between nitrogen and nitrogen. So that's pretty much it. Okay, we can also talk about this. The homolumos. Homo stands for highest occupied molecular orbital, whereas LUMO is the lowest unoccupied molecular orbital. So the HOMO would be sigma 2p 2, pi 2p2, pi 2p4 here, then 0, 0. And the LUMO would be pi star 2p0, or more like pi star 2p. So that would be the molecular orbital of N2.